You know, this is video that this that you know, this esp32 camera module is producing. So, you know, that little bright, you know, see that little clip there, little white clip the camera hooks into? That actually broke. So I was lucky to, you know, be able to just kind of stick it back in there and have it stay, but it's actually broken off. I was about to send it back, but anyway, the programmer worked great. You know, you can see the little programmer right there. Um, so right there is a programmer. Now I have, you know, the jumper on that actually set. You know, there is a jumper on this thing, and it's you know, got the option of a 3.3 volt or a 5 volt, but you actually set it to 3.3 volt. Um, you know, so that you can actually stick this power line on the 5 volt leg and actually have it power your 5 volt wiring point on this Arducam. Now, the reason I did that is because, I mean, at first I tried it in 3 volts. I actually have a pretty powerful 3 volt regulator that I actually hooked to a you know, 1+ amp wall pack. It has a variable voltage, so I can actually set it to a bunch of different voltages. It's kind of handy for things like this. I don't want to bring my laboratory supply over here because that would, you know, that would be kind of a mess. It's already a mess over here as it is. But but in any event, you know, I had a good regulator, but you know, at 3.3 volts, it wouldn't work for some reason. And I kept just, it just wouldn't recognize the camera. I mean, it kept giving me a don't recognize the camera message. You know, because see, you got to take that, you know, to program this thing, you got to take that wire and put it across the ground and like one of those ports. You can see kind of which one it is. It's actually the one right next to where that's plugged into on this side. So it's like the third one from the end, I believe. Yeah. Well, yeah. I think so. But at any rate, you know, you can see it in instructions on the internet. And the point is, there's plenty of instructions on how to wire this thing. Um, but the thing about it is that that's how you program it, okay? And then you got to hook the RX and TX lines up. Again, like some of these diagrams out on the internet showed. Let's see. I don't think I can pause this video while I try to find this for you. I wasn't expecting to make a review video. I was just going to document some of this stuff. Yeah, I don't see it right off the top of my head. I can't find it. I know I've got it on here. I just don't know where it is. Let me look. Camera. No, that's not going to be it. Well, anyway, the point is there's plenty of diagrams on this. So, this is one of them. Let me see if this has it. Oh, well, yeah, here. Yeah, see, here's a great example of one. You know, but you can see the wiring, see TX to RX, and then you go to the UDT and UDR line. So, you know, it kind of shows you how this works, and all these kind of look the same. So this is almost identical in appearance to the module I have. But then 5 volts goes to, you know, again, this isn't identical to the module we have though, because again, you can drive that to the 5 volt pin, but I guess you could do it like this too. I think this has a 5 volt output. Anyway, the point is that, you know, you do have to hook it to 5 volts, otherwise it just won't work. So, you know, and I tried like everything else, every combination of, you know, libraries and, you know, or whatever, you know, settings on, you know, on Arduino Studio. So, you know, you go into tools. This is what I use. You know, I got AI Thinker Cam. So, and in my case, I got set to port 9. And that's pretty much it. You know, when you set it to this AI thinker, which is toward the bottom of this esp32 section. So, but when you do that, there's almost no settings to worry about, so you don't have to worry about it. Supposedly, it'll also work at, you know, setting on a rover or something like that. So, you know, anyway, it's another option, I guess. But at any rate, you know, that's what I had to do. In order to get this stuff, you got to go into preferences, all right, and then you got to put, you know, this link right here. So in it, and you know, hit OK, and you know, and OK here. And this is the one how you get the esp8266 in here. You got to put this link in there and do the same procedure, but this is for the 32. So, but at any rate, you know, you go in there, you know, and hit OK. Then you go into your tools, and you know, you come down and just, you know, find your, you know, board, but you go select board manager, okay, and that brings up this, and you got to enter like ESP32 in here, and it'll find it, and then you just click install. So, and you do the same thing with the 8266, and that'll, after several minutes, it'll actually install all the close, damn it. But it'll actually install all the necessary, you know, board stuff, and also, you know, when you're running this for the first time, if you want to, what a piece of shit. I really don't like this Arduino Studio all that much. It's got a lot of flaws. I mean, I would say, hey, it's a open source kind of thing, but, you know, I don't know. What's that? Is it telling me I'm running out of memory or something? Stupid phone. But anyway, you know, the point is that's how you set this thing up. So it, you know, but yeah, the examples and so forth, you know, until you actually select one of the, like the ESP board, the examples didn't show up. So, you know, if you're running it for the first time, I guess that's what you need to do, for the examples to show up. Well, actually, it looks like the examples won't show up unless you have the proper board selected, because I don't see the 8266 samples anymore. So I guess if you have it selected as an 8266, the 8266 samples will show up, and the ESP32 will show up with the ESP selected in your tools. So anyway, but you know what was confusing about that is, you know, you think, well, geez, this looks like it has some Arduino stuff on it still. Well, that's not an ESP, but you know, but it really kind of doesn't. I mean, I don't know what this stuff is, so I guess it is chip select or dependent. I didn't know that. But at any rate, you know, the point is that was, you know, a little bit confusing for a few minutes. But yeah, this thing worked, you know, pretty nicely, you know, with all things considered. So, you know, so that, like I said, that's, you know, kind of how it works. So, but you know, and this is running at a high resolution, you know, well, super VGA resolution, and you know, when you start the stream, you know, hey, it's not half bad. Although, you know, if you touch this thing, it gets kind of squirrely on you. You know, because again, this is kind of wired like a Christmas tree, but you know, it's got a lot of lines in it and stuff. But again, I assume that has to do with the you know, with the wiring on this thing. So, but at any rate, you know, the point is that you know, it works, but you know, the lower the resolution, of course, the faster it works. So, you know, go into something like that, you know, it's almost instantaneous. Yeah, you know, if you don't mind looking at a postage stamp. you know, and then like I said, you know, even at this res, it's not too bad, you know, that's 320, and then of course, you know, the higher the res, you know, it performs okay at a regular VGA res. So, um, and I will say too, this room is actually not very brightly lit, although, you know, I do have these LED lights like turned up, but this is exclusively lit by LED in here. But you know, again, it's not really all that brightly lit. This actually performs way better than I was afraid it would in low light conditions, because I need it for low light conditions. So, but it actually works okay. And then if you actually turn the lights to where it's almost dark in here, it works great with a flashlight, and you don't need even direct light shining on things. So I thought that was fascinating. It actually really did quite nicely in low light compared to, you know, for a cheap camera. I mean, I'm real impressed with that. So, you know, because I mean, it behaved quite nicely. Now my Raspberry Pi camera is even better, and that's got the, I think this had the 2640 module on it, and this has got like the 56 or the, I forgot what camera module is, but it's by the same manufacturer. So, but that's the more advanced version of this. So, but again, that's even better. That actually works quite well in low light conditions. So, you know, it's pretty impressive. Um, you know, again for low light conditions, but again, it does slow down. Now, this thing is by default at 240 megahertz. I was rather shocked to find that out. I was thinking, well, maybe that's why it's so slow, because it's only running at 160, but no, it actually defaults to 240 megahertz on Arduino. So you don't need to set the clock, even though I have code in there where I can do that. Let's see. Got it off the internet. Well, I don't know where I put it. It was in the setup. Let's see. I think it was toward, well, yeah, see well, no, I'm not sure what this is. Oh, I'm looking at, what am I looking at? Oh, this is a different program. Let's see. Okay. It's this program here, this camera web server thing. Let's see. What the hell? So I didn't write this thing. So this is like a built-in example, but I actually took you know, the ability to set the processor speed. You know, here's well, you know, this is the algorithm you use anyway. These are two commands, and I do actually use the, you know, the get CPU frequency, and it's set to 40. So later on in the program I do, but at any rate, you know, that's the routine you use to get your, you know, at least your processor speed. But yeah, I mean, it's you know, out 240 megahertz. So I mean, you know, that's just, I guess it's just, you know, doesn't work very well, you know, at these higher resolutions. And like I said, if you take it to, you know, the maximum resolution, you know, it's real herky-jerky. So, you know, so, but, you know, the point is that, you know, again, the lower the resolution, the better it gets, and, you know, so, and this won't produce, you know, this is almost a square aspect ratio. It's not like a, you know, a widescreen format, so it's just something to take into account. But it's good that it's that way, otherwise it'd be a hell of a lot slower, I'm sure. Now, the face recognition thing works on this, but you have to go down to a, you know, a much lower setting, like this CIF at that minimum, and it you know, works, and you can actually have it record several pictures of your face, and eventually it'll recognize you. You know, not just recognize there's a face, but also recognize your face in particular. So, you know, which I thought was pretty cool. And it actually works on still shots too, to some extent. But like I said, you know, if you use the get still method, you know, most of that noise kind of clears up. But, you know, it's a little grainy, and again, it may actually do better the brighter it is. But, you know, but you can even take it up to, you know, the maximum resolution. And it doesn't look any different because I think it scales this image to fit the window, but but this would actually be taller, because this is just you know an HD monitor, so it would actually be taller than my monitor here if I could actually display the whole thing. But like I said, I mean for the price, I mean being really, I mean, because this is like $12, with the programmer included, and if I didn't buy it with a programmer, I could have got it for like $8 or $9. So so it's hard to beat. I mean, it's like I said, it's a halfway decent little camera. And also, oh, by the way, let me see if I can find this. Let's see. Node. Let's see. Well, let me show you this real quick. This is that other program that I had, but it's for an. Well, it's not for an esp32. I don't know why it says that. I wonder where I got that. I didn't realize that actually said esp32 now that I look at it, but it's running on an 8266, and you can see I got this little, this little slider thing, and like I said, when I got a servo hooked to it, and you can see that it controls it over a web server. This is just a web page, so you can show it on your phone or whatever. And that LED, I got kind of a toggle algorithm, so that's why sometimes it gets brighter, sometimes it gets dark, because I actually have it. Well, I'll show you. Servo web, let's see. It's in the loop. Somewhere in the loop. Where the hell did I put that? Okay, yeah, right here. So I have, this digital write to D1 in this case, and I just put not digital write D1, so it'll toggle it every time it comes, every time it runs this through the loop. So, but that's why generally it's actually running at half brightness, because it's actually turning it on and off alternately. But when I actually adjust the servo, well, since it's getting delayed, it changes the dynamic of that. So our original program, I had it hooked up to a PWM algorithm and everything, and and I guess I'm freaking dyslexic or something, because I was beating my brains out for 2 hours trying to get the motor to work, but it turned out I just had the damn motor wires wrong. I don't know why, but I was thinking the brown wire was a signal wire for some reason, but I don't know why. All the diagrams on the internet don't say that. I'm getting really bad about that. Must have brain cancer or something. But anyway, but the fact of the matter is, it worked really well, and you got to remember, I mean, these servos only run at 50 hertz, so it's actually, even though it's a PWM algorithm, it's not really that big of a deal. So that's why even on this, you could actually run quite a few. And on an ESP8266, I figure, and you can find this out on the internet. And like I said, a lot of these sites are pretty good. Let's see. I got, that's why I like Firefox. I can organize all my bookmarks. It makes it easier to find things. I got literally thousands of them. And I can keep them organized on the side here. And when I put a bookmark in it, I don't ever use this favorites thing. I just I highlight the title and grab it and drop it. So that's how I do it. It just makes it so much more efficient. Now that's why I hardly ever use Chrome at all, because you just can't do that. Those idiots. You could do things like that in Internet Explorer, but hell, everybody's abandoning that. So I mean, it's really, this is about the only game in town. Let's see. Yeah, pinouts. Let's see. I don't know if I needed what was on here. It's a tutorial. Oh, well, this is pinouts. Okay. All right. So anyway, here's an ESP32. It says, you know, and I guess you can maybe look this out as this random tutorials, and you know the URL's a little hard to see there, but it'll tell you, you know, like on ESP32 in this case, you know, what the various pins are, you know, some highlights of its peripherals, you know, and you know, a decent pinout diagram overall. But it'll go one step further and provide you this table of telling you, you know, what the pins are actually used for at various points, including, you know, its situation and boot up. So, you know, and this, you know, anything that's okay, you can use it, you know, for input and output, you know, given the GPIO number. And this, you know, it says, you know, you can't use these because it's connected to flash, even though you've got a pin there, you know, it's connected to flash, so you realistically can't use it. So, you know, and I guess this is, you know, boot failure if pulled high, but it's okay to use it as an output apparently. But at any rate, you know, that's what I'm saying. You got the same thing for somewhere for an 8266. Which is not this one. Oh, here it is. Oh, damn it, that's what I had up. Anyway, but yeah, that's a random tutorials too, but it's based on the 8266 reference guide. So again, the ads on this thing are obnoxious, but it is good information. So you know, so it shows this module, you know, which is one of the small ones, and then it actually shows this radio module too. But then it actually shows the actual 8266, and then it shows a stupid mini too, but it still does go into some of the pinouts anyway. But this, you have to use a little more guesswork because it's showing the pinout for this one, not for the big one. So that sucks. But as it turns out, you know, I mean, it still shows you most of the pins that you can't touch. But as it turns out, you know, I mean, you got about, you know, 10 or 11 pins you can use. You can't use these because these are the flash memory pins, and you know, that's your boot up. You know, your programming pins that actually hook to the programmer. You know, so it really just has a USB to serial interface on it. And this is just an alternate location for this. And this is like a half-ass serial port, but the idiots that did this thing, you know, decided to put this flash control on it, so you only have a transmit serial port, not a receive. But at any rate, you know, these are actually all pretty much available. The 16 is an exception. Again, you can still reference this table down here for, you know, for some of the exceptions which do apply to a lot of these pins. But over here, you know, I guess you got this ADC0, but that's the only real usable pin, general purpose wise, over here. So, but I think this whole SPI port's available on this side. But other than that, it really is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, maybe 11 pins you got on this thing. But still, for a $3 or $4 chip, that's not too bad. But you know, but most 28-pin processors, like in Pics, for example, and I'm sure this probably applies to Arduino too, you know, you actually would have more than that theoretically, because you wouldn't have an external flash on. And if you didn't need this, you know, you wouldn't have to do that here. I don't know why they don't just build the flash into the damn chip, because then you wouldn't have to waste pins like that. But that's a lot of damn pins to have to waste, because it's like a multi-channel flash memory bus. You know, if you look at the ESP32, and this is why I was getting into this, well, that's not what I'm looking for. Oh, well, this is the, you know, that's actually a random tutorial thing. This is how I set up the camera. So, you know, so you can kind of do a web search for this or whatever. Oh, well, I guess this does have the pinouts. This is what I was looking for. But yeah, it's from the same site, so I mean, it gives you some of the. Well, this is actually a more specific tutorial, though. It doesn't go into the like pinouts as much, even though it does have them, but it's not really talking about the pinouts. I mean, there's no table here saying, you know, the pins you can and can't use. But then again, the reason probably is that you know, really you can't use any of them by default. I mean, if you want just actually a totally free pin, there isn't one. Um, Now that was, making me pull my hair out. You see, these are the serial lines you use to program it. Now, if you're not programming it, you can reuse these. And my thoughts are, well, you could actually take a toggle switch, put one toggle switch here and one toggle switch there. So when you want to program it, you have a double pole, double throw toggle switch, and you just throw it into program, so that the serial connects to it. But then when you want to, actually use it, then you throw it into, serial mode, and you just put like a delay or something in your startup routine, so that, after a couple of seconds, you better have that switched over so that your program will work right or whatever. So if you want to communicate with some other processors or something like that, like an Arduino or whatever, you can use those lines that way. And still have access to the programmer. So I mean, that's just a one way of doing it, I suppose. This thing here hypothetically might be usable, but this is the grounding pin, so I'm really not sure, because you got to ground this pin to that, like I was showing you earlier, to put it in program mode. So I'm kind of like, I don't know how that would work. Okay, if I set it to a, if I had an input coming in, it was a low input, is that going to throw it into programming mode? So you might not be able to use this thing. You might be able to use it as an output, though. I mean, maybe it wouldn't respond the same way. But if it didn't, well, I mean, how are you going to program it? But I guess you put it, you short that out, I guess, when you boot it up or something, and maybe that's how you do it. So you probably wouldn't want to, if you had this set up as an output, you probably wouldn't want to jumper that until you turn the power off. So, unlike how I normally do it. So I guess if you reset it and that's tied to ground, then it'll go into programming mode. So maybe you can use this. That might be the only available GPIO then. Now this one, because that's CSI, but this one is part of this. So, and all these pins over here are dedicated to that stupid SD card reader. Now, if you don't need that reader, theoretically you could disable it and free up all these lines and all these lines. Or, well, not all, this line and then all these lines. So that would free up like 7 lines. But an alternative, is that, again, this is one of those fancy schmancy high-speed SPI data buses. So it's actually got 4 data lines, and you can actually reconfigure it to be in 1-bit mode instead of 4-bit mode. And that will free up 3 lines. And you can configure it to be in 2-bit mode, apparently, and that would at least free up 2 of the lines. So that's apparently how to solve that problem if you need some extra IOs on this thing. Because I want extra IOs. I mean, I basically want to use this camera module, as a main, like, control interface, because it's got Wi-Fi built into it and everything. So, I mean, you can create a web server, on this thing and actually, like I'm doing over here, stream video, to this thing and have it also, control things, at the same time. So, and you don't need to write an Android app. So you can just learn HTML, CSS, and JavaScript, and you got most of what you need. And familiarize yourself maybe with a little Ajax and so forth. But I don't think you need PHP, because I don't think you're setting up a real LAMP stack or anything on this thing, and I don't think there's enough resources to realistically do that. But the point is that this thing really is a pretty nice little deal, if you go about it the right way. But there are some pitfalls. So that's why I wanted to tell you what some of those pitfalls are. Now this right here, is 8266, and like I said, you got about 10 lines on it available. And let me see if I can find the esp32 here. Again, same. I mean, I guess these random tutorials guys I got some pretty good stuff on here, I suppose, if you can get to it. Okay, thank you. Nice of you to join us. Okay, ESP32 pinout reference. So again, it's the ESP version of the same thing like I showed you earlier. But in the ESP, you actually do have a hell of a lot of lines available. And again, you get like 2 of these for $12. Whereas the 8266, is you can get like 3 of them for 10 or 11, 10 to $12. So yeah, and given the fact they all have Wi-Fi built into them, that's great. Now this, though, actually has Bluetooth built into it also, and the other does not. And the other also does not actually have hardware I2C, so you got to use software I2C. But I guess it's got a high-speed clock, so it's not that big of a deal to bit bang a 100 kilohertz signal. I don't know why they say it's limited to 100 kilohertz, because you got 400 kilohertz I2C too. I mean, you should be able to run that with no problem. But like I was talking about on another video about speed, this thing really doesn't have that fast of an I/O. Um, this chip, this chip's slower than an Arduino, but the esp32 is about the same I/O speed. About 4 megahertz is about the maximum speed signal you can generate, and the Arduino's the same. So I mean, even though this is a hell of a lot more horsepower to it than an Arduino, but still I/O wise, it can't generate any faster of a signal. But that's more than adequate for I2C or bit banging in general for most applications. But but I was kind of lamenting in that video why the like the Raspberry Pi and some of these other processors actually had really high speed I/Os. And you're talking 50 megahertz or more, on like some of the Raspberry Pis and so forth. Be it the I got a W over here too, but at any rate, whichever model you're going with, I mean, it's still amazing. But the reason for that is because they actually can access external memory. That's why they're pretty fast. And like I said, if you've ever done any work with actual microprocessors, like I have, I mean, I've worked with Z80s, 8286s, 6502s, 68Ks, 68020s, etc. The processor has to have a really fast bus. I mean, there's something to be said for having a conventional data and address bus. I mean, still nothing beats it. Even we got to use like glue logic. Oh, it's so convenient because it's a high-speed bus. And even doing interrupt vectoring and everything is just freaking awesome. What you can do with a real CPU. However, most of those chips are so slow these days by comparison to some of these types of things. Even to Pics, they're almost unusable, but it's a shame. I do miss the real CPU days, when you can actually design good hardware. It was fun. It was real fun designing it back then because it was, an interesting challenge with digital logic and everything. But because you do need a lot of glue logic. But the point is though, is this processor, this esp32 chip here, actually has a hell of a lot of I/O lines. So, and you can see it here. I mean, it lists them. Like there's a bunch of them available, and I think I counted. It's between 20 and 25. So, for your reference, like a PIC 18F. 46 series, for example, would have, like it's a 40-pin chip, but you'd have actually like 32 to 33 I/O lines or so that are actually usable on it. So, and you had 4K RAM on that chip, and I don't know, like 46K memory or something. It's like an 8-year-old chip, but anyway, the point is it had like 3 hardware PWM units and shitloads of analog I/O pins and just everything. It's crazy. The nice little processor. I just love the Pics. But you do need a programmer, but you can make an in-circuit programming by putting a header pin on it, so it works great. And the programs are like $40. And these days, they, since PIC owns AVR, you can actually program AVRs with them too. So PIC owns Atmel, but the PIC Kit 4 will actually program Atmel as well. So if you want to just get rid of the Arduino thing and just do direct, instead of paying, buying a $10 Arduino when you're talking about a $1.50 chip. It's cheaper to buy the $1.50 chip, and you don't really have that much advantages because you can buy your own USB to serial converter. I mean, that's what I used all these years, to actually interface to them, is a USB to serial converter. So it's just an external unit. It only costs like less than $10, and you can communicate with it. It's just like you have USB on your thing, and you can buy those chips because that's all Arduino has. They just have a USB to serial converter. That's what that's what some of these extra chips on here are. That little black one right there, that's just a USB to serial chip. That's all it is. But every time you buy an Arduino, you got to buy one of those, whereas you could just buy one of those separately and use it with all kinds of different processors if you do a lot of this stuff. I mean, in other words, there's not really that much advantage to an Arduino. It's just a little convenient, and if you're a hobbyist and confused about it, okay, but it is, again, if you're just farting around, it's kind of nice. I mean, but I'm saying, really, if you're going to do something, you want to save some money, just work with real processors. Because you can get, ABR Studio, which which Microchip makes. I know I've got it installed on here. It takes forever to install that shit. They're but they got ABR Studio, but they also have their own little program that handles ABR2 these days, the MP Lab, 10 or 12 or whatever the hell it is. But at any rate, it'll take care of ABRs too. But you can program in the same C++ pretty much you're dealing with Arduino, but it's a little more of a standard version of C++. So, but you got the same ability to program in Pics, although those Microchip assholes still try to charge you for an optimizing compiler, and I don't know what that fucking even really means. I mean, I assume that's more efficiently written code and a smarter compiler, so it cleans your code up better or something. I don't know. I don't know if it uses different libraries or what. But at any rate, the fact of the matter is that still irritates. That pisses me off about the PIC, but that's why, again, I just always programmed in assembly language when it came to PICs. Because it's actually a pretty easy, for this 8 or 16-bit chips are actually pretty easy to learn the assembly language. It's a lot more complicated to learn it with AVRs. Even though AVRs are a pretty versatile structure, they kind of remind me of the 68K, and the Pics, the DS Pics are kind of like that too. They actually have a bunch of general purpose registers, and it's just a different programming environment, and you got a lot more modifications you could do on the addresses and so forth. The PIC 8-bit Pics, don't actually have that, so it's more of a conventional processor, but it's still really straightforward code to like. It's actually pretty easy to learn, particularly in the 18F and above. You don't have to worry about memory segmentation like you do on the 12Fs and the 10Fs, and that gets kind of a headache, when you're trying to access RAM, even small amounts of it. But at any rate, but enough of that. That's like I said, there's a lot you can do with these things, and it's pretty slick. This is a little display, and this little thing is actually supposed to. It's pretty cool. I mean, I bought it for like $8 or something. It's a 1.6-inch display. It's surprisingly nice, but it's supposed to actually work with this thing. But of course, there's not enough pins to do that. But it's supposed to work with the esp32s or the 8266s. But I have it hooked to an Arduino, so it can run off that too, and it runs these standard little test programs just fine from GFX guys at Adafruit, I guess. And what else? But it's that my ultrasound sensor that I got, hooked up to that, so it's measuring distance, and at the same time it's got that microwave sensor right there. Which I bought like 5 of those for $10 or something like that. Man, they work. I mean, I can be like way over there behind that shelf in the in the other room, and that'll still detect me waving my hand. I mean, but it's so sensitive, you cannot adjust the sensitivity to it. So don't think about using it to detect mice or something, because it'll detect you rolling over in bed, I'm sure. So it's just too sensitive, and I mean, I guess you'd have to stick it in like a half-ass Faraday cage or something to adjust the sensitivity. I don't know what you'd have to do. A Faraday cage that's got flaws in it, like with pliers, you fuck up some of the grids or something. I don't know. I don't have a clue how you'd do it, but anyway, it's a pretty cool sensor, though. I mean, I still got to admit, but you wouldn't want to use it alone. You could use like a PER sensor like this, maybe in combination with it, which is often done in commercial microwave PERs. That's a little touch sensor, and that was pretty cool. But I have it disconnected from I had it just hooked directly to this relay. I think this PER sensor, I think I've got hooked directly to the relay too. Because a lot of these you don't even need a CPU. You can just actually plug these in. Um, you know, you can actually plug them into the, you know, just directly into each other if they, as long as the voltage is the same. And oh, well, by the way, too, if you buy any of those frickin', you know, like esp01 radios or whatever, you know, the 24, you know, they have those little radio communications chips. They are 3.3 volts. You know, don't accidentally plug it into 5 volts. So I gotta buy another one of those. This is a little PIC, by the way, development board that came with my PIC kit. So it's actually got an 18F series chip on it to play with. I was thinking about screwing with it. I haven't touched the things in like 5 years. I haven't done any PIC development in that period of time, but yeah. So anyway, yeah, it's pretty cool stuff. You know, and you know, by the way, these little relays and even the bigger relays, or not relays, but the you know, the servo motors, you know, you can actually drive a bunch of them. You know, that's what I was meant to say earlier. So you know, you could drive like 10 of those off this 8266, or you know, 12 of them off a PIC or whatever. Because again, it's only a 50 hertz signal. And oh, by the way, I got this little thing, you know, which is really cool from Amazon. You know, for like 11 bucks, and it can drive up to a 4 amp stepper motor. You know, I have it driving this NEMA 17 right now, which is only got, you know, it's only like a 0.4 amp. But it's real simple because it just, you know, you have a direction and then you just supply it with a pulse train beyond that. So the more pulses you supply, the faster the motor. So you don't supply any pulses, the motor doesn't turn. But you know, you hook up the direction, it does have an enable line. But it's really that simple. And these are opti-isolated. So that's why you need to supply a ground line. So that's why, you know, you got the ability to supply it, you know, like either way, you know, either, you know, common anode or common cathode, because they're independent. So, you know, but they are opti-isolators. So, you know, it's an independent from the, you know, the internal drive mechanism. So, but again, you know, you can operate this thing. And I've actually had this, it says that it's like what, 9 to 42 volts or something like that. But I've operated it down to 6 volts, but it'll start skipping a little bit if you do. But it still keeps pretty high torque. I mean, that's pretty amazed how much torque these little stepper motors put out. You know, I mean, again, just a 0.4 amp motor, you know, actually puts a lot of torque out. So, and like I said, you can actually get NEMA 17s if you got any like old floppy discs, you know, 5.5 inch floppy discs. Yeah, 5.5 inch floppy disk. You know, if you can find any of those, I mean, they have a NEMA 17 in them. I think old CD-ROM drives did too, but I mean, you're talking pretty old stuff because nobody makes floppy disks anymore. But anyway, it's nice to be able to find some of those in a junk box. So they do have NEMA 17s in them, and they do have fittings on them as well. But I mean, these motors are like 10 bucks a piece, but they do come with a bracket, which is cool because the bracket's kind of a pain in the ass, and it's actually a well-built bracket. The problem is the screws are too long, so you got to put like washers in it or something to make it work. So that sucks. But you know, but beyond that, it was, you know, not a bad price, and you can buy like a 3-pack for like 29 bucks or something. But I just bought one of them because I actually had a bunch of floppy disks lying around, and it turned out they had NEMA 17s in them. So I was like, well, that'll probably do me for that experiment if I want to, you know, do a CNC, because I did buy one of those like CNC shields. Wherever I put it. Where the hell did I put that? Yeah. Anyway, I bought one of those little motor shields that, oh, well, I don't know where it is. But yeah, I bought one of those little motor shields, you know, that actually have like, 4 stepper motor drivers on it, and they come with an Arduino for like, I don't know, 14 bucks or whatever. I bought this a lot of stuff on Prime Day. But anyway, you know, the point is that not all of it, but a lot of it. that was pretty cool, but you could only drive a pretty small half amp stepper motor. It's fine for NEMA 17s, but those little, small little modules they come with, I forgot what the number is, but they're you know, kind of wimpy. Was in the process of building a robot. About some of those wheel kits and a platform independently, but I hadn't gotten around to that point yet. I mean, I've tested the motor drivers, 298s. Those 298s can be configured, keep in mind, to run a stepper motor too. And really, if you wanted to buy like a little, 8-pin pick, or I'm sure AVR makes a similar chip, you could actually make a an 8-pin microprocessor probably control that thing. Because they usually have at least 4 or 5 I/O lines available, and you just need 4 to actually make a stepper motor driver. So you could actually make it so it works like this. So you supply a pulse train, and it handles the pattern stuff. So it just advances the pattern for every pulse you apply, and it reverses that if your directions reverse. It's actually a really simple little algorithm to write, even if you did it in assembly language, let alone C++. But the point is that you buy a little chip like that, you could hook it up to these little $2 or $3 modules and actually make a stepper motor driver that's probably like $4 or something, that actually works the same and can drive 2 amps per phase, take care of a 2 amp stepper motor. So it's not bad, that you can do that. Now it probably won't microstep or anything, and this son of a bitch will, it'll microstep, pretty damn good. But the point is that it can still be a basic stepper motor, which is fine for most needs. Most of the time you don't really need microstepping. So really just doing 200 steps per revolution is usually more than enough for most simple applications. But anyway, those freaking plastic motors are neat, and they put out quite a bit of torque. But man, those suckers, you can't run them long. They'll start to want to burn out on you, even if you're supplying it. I guess they're 6-volt motors, but if you're supplying it around, with around 6 or 7 volts, I mean, you can't run them long. They'll start to, crap out on you. So, that they are cheap plastic motors, but anyway. The only other thing I had is, I did buy an AT Mega with one of those little touch screens on it. I hooked it up over here since I'm out of room on my USB ports, but anyway, and this is an actual touch screen because you can actually touch it with an inanimate object, unlike a cell phone, and it'll actually work. So so anyway, it's pretty cool. That's hooked an AT Mega, but keep in mind an AT Mega does not have really any more processing horsepower than an Uno. I mean, it's not a faster chip. I mean, it's the same. It's an 8-bit processor. The only thing different about the Uno versus the Mega is the Mega has way more ports. It has way more I/O lines, and it has 8K of RAM instead of 2K, and more program memory. So it's just a fancier version of the same chip, but if it's just raw processing horsepower you need, an Uno is more than adequate. Like this thing's, driving all these different things all at the same time. I mean, because I actually got this, this card reader running on here, and this little gyro sensor. So, that's what this is, a little gyro sensor, and, so like I said, it gives you readouts on, the serial port if you have that hooked up, or turned on, your little serial reader or whatever. But yeah, I mean, it's pretty slick. But I mean, it's it's doing all this stuff, just with an Uno. So simultaneously, including running these displays and everything else. So I mean, it's like I said, an Arduino actually has a lot of horsepower. But again, it's about the same speed as a PIC 18F. In terms of computational power and everything. But again, an 18F 46K22, which is the one I used to be fond of, had 4K of RAM instead of 2K. So, it did have more RAM than this particular chip, this 328. But again, not as much as a Mega, but you can get the DS Pics. Even back then, with 16 or 32K, and these days, I mean, geez, you can get them for a lot more than that. And they do have pins on them too. I mean, they're ICs, you know, that you can actually stick in a breadboard. They're not surface mount. So you can buy them like that, and that's why I like them, because they're actually easy, they're experimenter friendly. Because Pics, you got to understand, Pics used to rule the roost. I mean, back in the 90s and the early 2000s, I mean, Pics, you know, hobbyists really didn't ever touch AVRs. They didn't touch Atmos. I mean, Pic was the shit. I mean, that was the end thing. If you were a developer, an embedded hobbyist or whatever, you knew how to program a Pic, and usually you knew how to program it in assembly language too. Even though C++ was available too, and that started becoming more popular in the late 90s for those embedded systems. But you know, but the point is that, you know, yeah, they, you know, the Pic, you know, 84, you know, was the I forgot what the number, 16F84 or something like that, was real popular with hobbyists. I mean, there were tons of books written about it, etc. I mean, um, you know, you can find them at, like, you know, in the used books section at Amazon if you're interested. But you know, you know, like I said, forever that was a real popular processor, but it was, you know, 16 series is still nowhere near the 18 series. But at any rate, you know, like I said, you might want to consider that, you know, if you do screw around with this kind of stuff, it's actually not that big of a deal. You know, there are a few rules you got to look at and everything, but you know, to work directly with the chips. But you know, if you're just doing it on a breadboard, it's actually not that big of a deal to use those things. I mean, they're almost as good as using an Arduino, because, you know, you take like an 8-pin processor, there's really not a lot to it. I mean, you got a power line, you got to supply power to, okay, and then you got like a ground, okay, and, you know, and of course you got to be able to program it, you know, which, again, if you do it in circuit, yeah, you got to, you know, have some programming lines going to it, and it'll take really 2 of the I/O lines, and you are going to have a reset line. So again, you know, you're going to have like 4 or 5 signals on an 8-pin chip that you can use on a regular basis. Again, if you just do temporary programming, though, yeah, you can have a few more, or a couple more. Like I said, I think it's like 5 or 6. You know, would be the maximum. It's probably like 4. You know, you can kind of count on it. But still, you know, it's easy to program, and once you got the program in the damn thing, you know, you can go stick it in your application. You know, or again, you can build in-circuit programming into it, you know, by just putting a header on it and going to the right pins. But you know, the point is that it's just about as easy as one of these. If you're just putting it in a breadboard, it's actually not that complicated. Dealing with those simple little processors, I mean, you know, they're cheap too. I mean, they're less than 50 cents. So you can pick one up, and it's not a Chinese ripoff either. I mean, it's the real deal. So you can go buy them through Mouser or DigiKey or Nodemcu. But Nodemcu is going to be more expensive on stuff like that, but still they're a little more hobbyist friendly. But then again, Mouser and Nodemcu and DigiKey are really hobbyist friendly these days. I'm surprised by that, because they've actually got way better low volume pricing and so forth than they used to have like 20 years ago. I mean, 20 years ago, really, you had to buy, you know, kind of bulk quantities before, you know, before you could get any kind of good pricing out of them. But you know, these days they're not that bad. You know, they actually have a lot of hobbyist stuff too. So I guess they're trying to get in on that market these days. But at any rate, you know, the point is that you know, it's kind of a state of affairs, you know, with that, and that's just a, you know, a few observations that I can make about some of this stuff. I know this video ran way longer. I didn't expect it to turn into a review video or whatnot, but I really just was going to scan my camera around, just kind of show what the wiring is and some of this stuff, you know, in case I ever wanted to sort of recreate this for some reason. Because that's what I don't like about, you know, you got to build, like, you know, about like all these sensor kits, and you got to build all these things, then you got to tear them apart, you know. I mean, unless you want to take the time to really turn them, you know, it's like this little ultrasonic thing, man. I'm half tempted to turn that into a device. But, you know, really, I mean, do I need it? And you know, I mean, because I could 3D print me a case, and you know, but I mean, shit, I mean, I got other things I got to do. I'm trying to build a robot here, so and not this one either. That's just the stepping stone. You know, that's a Bluetooth module too, so I used that for my sign project a couple of years back. But anyway, you know, these 8266s, man, I can't you know, tell you enough about those. Those are just slick as shit. So, and they also, I never really heard of these before, but they got these teensy processors. Oh, whoops, damn it. Uh, come on, damn it. Okay. All right. Yeah, but teensy. Okay, any day. It's an older computer, so it's slow. Um, but yeah, these teensies, like 3.2 to 3.5, these are really badass processors, especially these 3.5s, and they do have the new 4.0s. Although they're cheaper to buy like on the internet. You can get them for like 19 bucks for the 4.0s, but again, that's as cheap as they get though. That's what sucks. They generally range from 20 to 30 bucks. So they're almost the price of a Raspberry Pi and more expensive than a Raspberry Pi W, which is actually more powerful than these things. What I don't like about Raspberry Pi W, like I said in that other video, is that you're stuck with an SD card, and those just aren't, in my experience, that reliable. Especially if you're doing something like a robot. I mean, what happens to those jiggle loose? I know they're low mass, but still, I mean, given the fact that it's just sitting here on a table, those damn things tend to burn out on me. Um, it happened in that W, the card burned out or something, and this card burned out on it, and I had to replace it. So I've had them burn out in cameras and just everything. Even this phone here, the damn thing only works sporadically. I'm recording to an SD drive, but you may not ever see this video because it's going to the SD card. So who knows? I'll try to download it as soon as I can. Um, but yeah, this thing, these are really, really powerful though, especially these fours. I mean, these clock in at like 700 MIPS or better. So I mean, they're definitely in between an 8266 or an ESP32 and a Raspberry Pi. So they're like they're filling that hole, but they are almost as expensive as a Raspberry Pi, which pisses me off. But they are an embedded processor. I mean, it actually has the embedded program memory and RAM and everything on it. So it's just like an 8266 module will be. I mean, again, if you buy one of the Nodemcu type modules, that look like this, it'll have features on it like that. But the difference too is this actually has real USB attached to it. So, I mean, apparently you can actually have a full speed USB bus with this thing. Full, like an Arduino, it has a USB to serial converter. So again, most you can go up to like 900, kilobaud or something like that, almost a megabit. But this, you can go up to the full 450 megabits, and they got the horsepower to actually do something with it. I mean, they're really impressive little chips. I just wish they were cheaper. And apparently there's a lot of different people that make these things. So like here's Teensy 2 has an Atmel, they're ARM-based chips, very ARM Cortex, kind of similar to a smartphone or the Raspberry Pi. Um, but the point is that they're really powerful. I don't own any of these, but I mean, if I needed something that had more horsepower and a hell of a lot of I/O lines and PWM lines, and I mean the ADCs and DACs. I mean, this has got like peripherals out the yin yang. These things do. You can look at one of these, for example. Let me see if this. Oh. It's one of those lame ass suppliers that don't supply any real pictures. But some of these, yeah, this one might be a good example. You look at okay, that. Okay. But you look at the back of it, and well, some of these actually have a lot more pads than this, but you actually see on the backs of some of these, they actually have pads all over the damn place. I might have even, well, I don't know if I've seen any 8266s that way, but You know, so you got pads on the back of the board and on the top of the board, and has all those I/O lines. And again, they come in a lot of different configurations, but the point is these are really, really quite cool. Like I said, 32-bit. Now this is their cheap, their LC version, and that's not that fast. It's only running at 48 megahertz. Their baseline unit, ran at like 80. For a teensy 2 or whatever. Um, but still, I guess it's got 8K of RAM, but who knows how much RAM that actually is. It's just like in these damn 8266s. I mean, you think, oh, it's going to have 512K RAM and all this stuff. This stuff, well, don't count on it. I mean, you're going to have like 50K left or something. I think you can free up a little more. And as far as programming memory, I don't know. I mean, it's so confusing how they have the memory structure on these things set up. I mean, I have not figured that out yet. I don't know why they're so dodgy about it, but it's just kind of hard to get a straight answer out of any of those assholes on what the actual frickin' memory configuration is, and how that all works. But you'd think with the overhead, how much? Because like I said, there's like 200 meg or no 200K or whatever that's actually used by default. So I guess that's by the TCP stack and all that. But you can turn that stuff off, and it won't use that much memory. But yeah, I mean, it actually eats up a lot of your program memory space. So it's pretty shocking if you think you're going to have a whole hell of a lot of program memory. But you still have plenty left compared to a PIC or something like that. But I'm just saying it's not as fancy as it seems. So I mean, so I kind of wonder, just like on these things, how much of this is really true when it comes to RAM, and program memory. But again, generally these things are actually pretty badass. Oh, oops. If not, kind of expensive. I don't know why they're so chintzy with their headers. I mean, really, without pins, and they charge like an extra $5 because they put fucking headers on it. Uh-oh. Well, I gotta go. The batteries are running out.